Okay, so we are going to answer one problem on uh, force, how we apply integration when solving force problems. This is one of those problems. So essentially, um, first thing we do is draw the diagram, or basically the shape in a Cartesian plane. So it says here, we have an isosceles right triangle. So it says the hypotenuse is 12 feet. What we mean by isosceles is that two sides are equal. So, okay. Submerged vertically. Um, I already know the answer, but I want to still try if it could work with this kind of orientation. Because supposedly the orientation is like this. Specifically, the reason why the triangle is exactly at the center of the Cartesian plane, like at its very center is the origin, is because it says here, if the vertex is 3 feet above the surface. So we're going to assume that the x-axis, or y is equal to 0, is our surface. So the vertex is 3 feet above the surface. Before that, let's draw a small triangle here. Let's identify already the sides of this triangle. So we have a hypotenuse. Again, this is a right isosceles. By 45, 45, 90, 12 is x square root of 2. And then the other sides are just x. We can do that, or we can use Pythagorean theorem, but I think this is more convenient. X is equal to 12 over square root of 2. Square root of 2, square root of 2. Rationalize 2 square root of 2 over 2. This is 6 square root of 2. So these are the sides, 6 square root of 2. Okay? Okay. Okay. We want to identify the length of this line. So from the vertex over here to the midpoint of the hypotenuse. How do we determine that? So let's draw first the triangle in the Cartesian plane. It says 3 feet above the surface. So let's say this is 3. 1, 2, 3, 4, 6, 1, 2, 3, 4, 5, 6. I'm trying to make the scale 1 by 1. So each box is 1 unit. So it's easier to visualize. This is, again, this is 12. This is the hypotenuse. This one is 6 square root of 2, 6 square root of 2. This is equal to what? So we know that this distance is 6, right? It's just a half of the hypotenuse. So it's the same here. 6 also. We know the side of this as well as this. We can identify the other side. We can use Pythagorean theorem. So a squared plus b squared equal to c squared. 6 raised to 2 plus... Okay, the hypotenuse is 6 square root of 2, right? Okay, 36 times 2 minus... Transpose this to the right side. 36 times 2, 72 minus its half. It's just going to be 36 again. So b squared, b is equal to 6. Positive, negative 6 to be specific. But practically speaking, we disregard the negative value. There's no such thing as negative in this tangible world, if you get what I mean. I mean, essentially, this is, it has to be greater than 0. So this is 6. Okay? We're going to use a horizontal element. Usually that's, not usually, always. By default, that's what you use. So I'll just remove the red line. I will write the horizontal element in red so it's distinct. And ideally, I mean, supposedly, this is the area that we have to compute for. Again, it says, find the total force on one side of the plate. The total force on one side is this entire side. So, yeah, it's pretty simple right now. Okay. Okay. We have this formula. dF is equal to WHDA or WADA. It's kind of a pun. It helps you memorize. But this is the actual full formula. F is equal to the density times integral lower limit and then upper limit times the height, which is YA minus YB. And then the width, dA is the width times height, right? X sub r minus x sub l times dy. dy is the height. It's just a small, really small value. So usually we just leave w as a constant. We don't substitute until the last, until we get everything done in the right side. Limits of integration, since this is a horizontal element, we look at this and this. This part is 0, 0, the origin, right? When we go at the very top, it says again, we drew our illustration based on the instruction that it says the vertex is 3 feet above the surface. So this one is 0, 3. Okay? Below, okay, so since we determined that this is 3, the total height, this height is 6. So what remains from the origin to the very bottom is also 3 units, so 0, negative 3. So like our limits of integration are negative 3 and positive 3 from here to here. Essentially, the horizontal element can move from anywhere as long as it's within negative 3 to positive 3. So yeah. YA minus YB, how do we determine that? By default, usually the surface is over here and it is, for example, the surface is 4, y equal to 4, 4 minus y. This one is, the y is basically here. But in this scenario, it's, I think we're going to use a different approach. What kind of approach? I think it's just y itself, although I'm not sure. Correction. We are only going to account for whatever is submerged. Now it makes more sense. Find the total force on one side of the plate. If the vertex is 3 feet above the surface, so anything that's from here to here, we don't account for the total force that applies there. Rightly so, I suppose. Therefore, we only account the one here. So we move the horizontal element. It can only move from here to here. Therefore, our limits of integration, we will limit it to, from the origin, 0 to negative 3. So this one is 0. Okay, so YA minus YB. So the surface is here, right? So 0, 0 minus y. That is going to be our height. So coming from here, y equal to 0 to, theoretically, this is one of the positions that our horizontal element can be situated in. So this is the height. Height is equal to ya minus yb is equal to the surface minus y. And that's why it's 0 minus y. When it comes to the width, it's basically just, specifically the x sub r is this. And the x sub l is this. It's easy to identify x sub l, it's just 0. So how about x sub r? We're gonna need to make an equation of the line. Equation of line. Using 2 points. This is the line that we're interested in making an equation on. So this point will be used. We need to identify what this is. The reason why I made the illustration measurable by 1 unit. So each box is 1 unit. So it's easier to trace what this is. Coming from, okay, so 0, this is 6, right? So x is 6, and then below, same level as this, -3. So 6, -3. Using the points 0, 3, and 6, -3, so we need to find the slope. Slope is delta y over delta x. 3 minus -3 over 0 minus 6. 6 over -6 equal to -1. M is -1. Makes sense because the line is going that way. If it were this way, then the slope has to be positive. So we're on the right track. So point slope form, I believe, y minus, let's use this point, y minus 3 equal to -1. That's the slope. X minus, and then 0. Y minus 3 equal to -x. Okay, that's it. And it says here x sub r, right? So we are gonna express, actually, yeah, we just have to express this in terms of x. So x is equal to, you transpose the negative to the other side, it's gonna be -y plus 3, or 3 minus y. Okay, so that is our x sub r. 3 minus y, and then minus x sub l is, again, 0. So dy. Okay. W, just simplify before we integrate. -y times 3 minus y. By the way, since this is a triangle, we are also accounting for this area, right? Not just this. So that means we have to put over 2 in the left side of this equation. And we'll transpose it, it becomes 2w at the right side. Okay? That's going to account for the area or the force on this entire side. If we don't put divide by 2 here, that means we're only accounting for the force here, not here. So it's just common sense. 2w, 0, -3, -3y plus y squared dy. Okay, we're ready to integrate. Y raised to 2 over 2 plus y raised to 3 over 3. Easy. Integration is easy. It is just the analysis aspect that is not easy. So 2w 0, no? -3 times 9 over 2 plus the 27 over 3, 9 over 3. 2w times 27 over 2 plus 3. LCD 6, 33. 33w. Are we on the right track? Doesn't look right. -3 raised to 2 plus 1. So far so good. This one's correct. Maybe it's in the arithmetic. (29 times 3 times 3, 9, 27, 3, 27 over 3. What is 27 over 3? Oh, frick. Ah. 27 over 3, this one. -3 raised to 3 over 3. This is odd, so just leave the negative outside. This is 9, not 9 over 3. Okay. That was my mistake. Okay, we're good so far. 18. 18 plus 27. 15, 35. 35. Wait, really? No. This is supposed to be 45. I'm tripping. Okay, so we got 45 W. What's the liquid substance here? It's water, right? Usually the answer, it would be enough to just label it as 45 times the density of whatever the liquid is. In this case, it's water. But if you want to, by default, it's a constant. The density of water in terms of pounds per feet cube is 62.4. For salt water, it's 64, but you don't have to know that for now. So like, you just multiply. 45 times 62.4 is, well, you decide. But this answer will suffice. Okay, next. What if we're given this question? So the face of the gate of a dam, wait. This is